use algebra to solve this equation over the domain negative pi to pi. So looking at this equation, we've got a quadratic equation. When we have a quadratic equation with a cosquared and a cos, or a sine squared and a sine, how do we solve quadratic equations? Well, we move everything over to one side. And make it equal to 0. Once we've made it equal to 0, the next thing we would try to do is factor it. Now, if you tried to factor this one, okay, if I try to factor this one, don't write this down because I'm going to give you it, tell you right away you can't factor this one. But if you tried, the only way that you can get 3 cos squared is if it was 3 cos and cos. And the only way you can multiply to get 1 is 1 and 1. So if this was factorable, this would be one of the easiest ones in the world to factor, because you only had one choice for your first terms and one choice for your last terms. And the next thing you'd have to figure out is whether they should be both positive, both negative, or one negative and one positive. And since it's a negative 1, you would have to have one of them positive and one negative. So that's a possibility, or this one could have been negative and this one positive. But no matter which one of those I choose, when I check my outside and my inside, I'm going to get 3 minus 1 or negative 3 plus 1. Does that ever make 1? No. So when trying to factor this, it becomes apparent quite quickly that we can't factor this. And if you can't factor something and you're solving it, you're going to have to use your quadratic formula. So using your quadratic formula, cos x equals, because we don't have x squared, we have cos squared x, negative b, so negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c over 2 times a. So we get cos of x equals negative 1 plus or minus the square root of 13 over 6. And this can be split up into 2 separate equations. We would have cos of x equals the negative 1 plus the square root of 13 over 6, and cos of x equals the negative 1 minus the square root of 13 over 6. In both of those cases, we have values that are not on our unit circle. So we're going to need to find our reference angle. This question's in radians. And so I'll go to my mode and I'll change it to radians. Would you like me to make a sneaky mistake and see if you can spot it? You want to try? Okay, I'm going to try and make a sneaky mistake and see if you can catch it. Okay? Next step in both of these is finding your reference angle. So for the first one, I'm going to go cos inverse. I'm going to use my fraction button. And it was negative 1 plus the square root of 13 divided by 2. And, oh, I get an error. So I'm going to write error. And in the second one, I'm going to do second cos inverse. Go to my fraction button. Negative 1 minus the square root of 13. Oh, I didn't write 6. That wasn't the sneaky mistake. Oh, I'm still going to make a sneaky mistake. That was just a silly mistake. So let's let's try the first one again without the silly mistake. Oh, but you guys are paying attention. How many people, oh, I found the mistake, it wasn't so sneaky. Okay. Oh, it's not an error. So reference angle 1.21. That was just, as they say in English, a red herring. Have you learned that in English yet? Sorry, this isn't an English class. Okay, so the reference angle 1.21. Now we'll find our reference angle for our second one. So our second one is exactly the same, except there is a minus sign instead of a plus sign. So I'll change that to subtract, and a reference angle of 2.45. All right. Okay. Before we go on to solve for x between 0 and 2 pi, I've made my sneaky mistake. Did I just copy it down wrong? 1.12, I got, okay. That's sneaky, but that wasn't supposed to be it. Man. Oh, but that was good. I should get you guys always to look for sneaky mistakes because you'll find all my mistakes that I'm not going to catch. Yes? Right. When I did the reference angle for the second one, this is a negative answer. So my reference angle, if you look at this answer, reference angles are always between 0 and 90 degrees, which in radians means that they'd have to be between 0 and pi over 2, which means they have to be between 0 and about 1.57. And that is past 1.57. But you're not used to radians, so you'll not catch that, especially when the fraction's like this. We have to, when finding our reference angle in the second one, I'll rewrite the second one. That's a negative answer. So I need to make that fraction positive. I can make that fraction positive in two different ways. I can make the entire top positive, or I can insert a negative on the bottom. When I push enter, now my reference angle, 0.696. That answer is between 0 and pi over 2, because we always do our reference angle of a positive value. We also need to determine whether these fractions are positive or negative, because once we determine this fraction is positive, these answers are going to be in quadrant 1 and quadrant 4. And this fraction, because it's negative, these answers are going to be in quadrants 2 and quadrant 3. So for this one, in quadrant 4, in quadrant 1 it'll be exactly the same. And in quadrant 4, I'd have to go to my calculator and go 2 pi minus my reference angle, which I'll steal from up here, 5.16. And these answers in quadrant 2 and quadrant 3, I'm going to steal this answer here and store it as x. And then in quadrant 2, it'll be pi minus my reference angle. In quadrant 3, pi plus my reference angle. Wow. And 3.84. Now, both of these answers are answers between 0 and 2 pi, once around the circle. What were we asked for? We were asked from negative pi to pi. So our final answers for this question, x equals, from negative pi to pi, anything in quadrant 1 and quadrant 2 is still going to be positive. So our answers in quadrant 1, 1.12 and 2.45, they're going to be fine. But our answer in quadrant 3 and quadrant 4 have to change. So this one was in quadrant 4. It's coterminal with negative 1.12. This one is in quadrant 3. It's coterminal with negative 2.45. How did I know what they were coterminal with? Well, if this 2.45 is my answer in quadrant 2, my negative answer in quadrant 3 is like going to quadrant 2 in the negative direction. So it's going to be the same value at 2.45. Did it ask for the general solution as well? Yes. So our general solution, the reason we like to solve it between 0 and 2 pi to begin with is I can take those four answers, x equals, all my answers between 1.12, and the order doesn't matter, 2.45 and 3.84, and add 2k pi to each of them. (12, 13, and 14 for practice.